Welcome back to my channel. In this video, we are going to discuss about the linked list. So linked list is a linear data structure which can be defined as a collection of objects which is called nodes. These nodes are randomly stored in the memory, unlike array. In the array, we have contiguous memory locations, but here in the linked list, we will have randomly stored memory locations. So let's take one example of the simple singly linked list where we have total 3 nodes. So this is I am making a singly linked list. So in a singly linked list, a node contains 2 fields. So in this particular node, one field is for data and the another field will contain the address of next node. And the finally, last node will contain the null pointer. So here we can have data like 2, 3, and 4. And here we will have the address of the next node, that is address of 3. Here we will contain the address of 4. And here we don't have anything after that. That's why here we will have null pointer. So why we use the linked list? So linked list is not required to be continuously present in the memory, and if we store this in the randomly memory locations, then it will help us to achieve the optimized utilization of the memory. Linked list doesn't need to be declared in advance. For example, in the array, we know that we have to declare the size of the array in advance. But here, the linked list will be dynamic data structure, and dynamic data structures don't require to do that memory allocation in advance. And linked list, we can allocate the memory according to our requirement. And whenever we want to delete the node, we can delete the node and we can deallocate the memory. So our memory will be free. So that's why linked list is very important data structure. If we talk about the comparison between array and linked list, then array has certain limitations as compared to the linked list. The first thing, as I already told you, that the size of the array must be known in advance. In advance means whenever we talk about static data structure, then it will have memory allocation at compile time. Okay, so this is one kind of static data structure. That's why this have some limitation. All the elements in the array need to be contiguously stored in the memory. So inserting any element in the array needs shifting of all its predecessor. So you can see that the lecture of array operations where we have done insertion into the array and deletion into the array. So if we do that, we need to shift all the elements either on the left side or right side because the memory in the array are contiguously stored. So that is why this is one of the limitation of the array. We will compare the array and linked list in the next slide. Another thing, if we want to change the size of the array at runtime, we cannot do it. In the linked list, we can do it. Even we can delete the memory also, and we can create the memory also. So in C language, usually we use the memory allocation using the malloc function and calloc function. So how do we create the node in the linked list? So if you want to create a node like this, then how we are going to create? So here we are going to use the user-defined data type that is called structure. The structure syntax is like this. Inside that, we will store some elements like we have data, and the first field will contain the data, and next is the pointer to the next. Means this is your pointer to the next. Here, 2 more pointers we are defining. That is head and PTR. One pointer head will point to the first node of the linked list, and the PTR we will use for allocating the memory. So here you can see PTR is equal to struct node pointer malloc size of struct node. It means this function will create the memory of size the node. In the node we have two things, data and pointer next. So this thing you need not write in the C language. Okay, just you can write malloc size of struct node and it will create the memory in the node. So in summary, if I tell you about the linked list, we can say linked lists are dynamic in length. We can change the length of the linked list at runtime. Then arbitrary memory locations. Arbitrary memory locations means randomly memory allocation will be done in the linked list. Access. How can we access any element? If you want to access any element in the linked list, simply you can use these links. With the help of these links only, we can have access to the elements and we can insert and delete using these links. Data is stored in sequential manner. As you know already that it is a linear data structure. In the linear data structure, you can see the data is sequential. It is a dynamic data structure as we know that the length can be increased or decreased at runtime. Here, efficient memory utilization will be there. Why? Because we don't require huge amount of memory for that. For example, if you want to declare an array, then we have to declare the array big enough, for example, 100. But let's suppose if we are not using this, if you are using only 60 or 70 elements only, then 30 will be wastage. But here in the dynamic memory location, we can use memory properly and we can delete the memory if we don't require. Element of linked list are called node. That is, you know that we are using nodes. Now we will compare the array and linked list. Array are stored in contiguous location. As I told you, linked lists are not stored in contiguous memory location, although it is sequential in nature, but they are not stored in contiguous memory location. Array is a static data structure. When you have static data structure means the size is fixed. Linked list is a dynamic data structure, means the size can be changed at runtime. So we can say that third point, the memory is allocated at compile time. In the linked list, memory is allocated at runtime. Fourth, it uses less memory than linked list. Why it uses less memory? Because here we don't require to store the address of the next node. Don't require the address of the next node. That's why the memory requirement will be less in this. It will use more memory because it stores both data and address of the next node. So in the array, if I want to use 5 elements, so only I will require these 5 fields. But if I use here, then I will use 2 fields for every node, like this. In this way, the more memory consumption will be there. Elements can be accessed easily. So that is one plus point of the array, that we can access any element using the index. If I want to access any element, let's suppose I want to use this index 3. So I can easily access this element by using a of 3. But here we have to use some pointer and we can start from here only. So traversing is, or we can say accessing the element is here difficult. Insertion and deletion operation takes time. Means if you want to insert and delete the element in the array, an array is not suitable. option. Instead, we can use the linked list that is better for the operation insertion and deletion. We will discuss now the types of linked list we are going to study. The first is singly linked list. In the singly linked list, we have only one arrow which is pointing toward the in the forward direction like this. So this is called singly linked list. Here first node is called head. So the advantage is this is very simple and it will require less memory than other kind of linked list. Drawback or limitation is we cannot go in backward direction. If we want to go in the backward direction, we will need doubly linked list. So that I will discuss. Circular linked list. In the circular linked list, as the name suggested, circular means the last node will be connected to the first node of the linked list. Then it will become circular linked list. So in circular linked list, we can continuously go to the next node and we can do the circle round. So advantage is we can traverse continuously. Limitation or drawback can be we cannot go here also in the backward direction. If we coming here, let's suppose we are on the X, then we have to move forward only. We cannot go backward. If you want to go backward, then we can use the doubly linked list. So if you draw the doubly linked list, in the doubly linked list, we will store three fields. One will contain the data. The previous field will mark previous pointer and the next will mark the next pointer. It means we can go in the both direction. So our nodes will be connected. Nodes will be connected like this, where we can say 6 to previous was 7 and 7 to next is 6. So in this way, this is called doubly linked list. So if this is the head node, then the previous pointer will be null and the sixth is last node, then next pointer will be null. Because the previous pointer is not present in the head and in the last node also we don't have next pointer. So in the doubly linked list, we can traverse in backward and forward both directions. Limitation can be it is requiring more memory. Why? Because we now have three fields for every node. Earlier we have two fields for every node. So memory consumption will increase. Last is circular doubly linked list. Here, this is the combination of circular also and doubly linked list also. So both advantages we can write here that we can traverse backward and forward also and we can traverse continuously also. Limitation is it required even more memory and it is complex. Or maybe it requires less pointer also because we are having a doubly linked list. So in our next video, we are going to see about this all kind of operations performed in the this type of linked list.